All right, chapter 6 is all about rational expressions. What is rational expression? Well, if something's rational, it's a fraction, okay? So we're going to be talking about expressions that are in fractional form. Like, so we have an expression in the numerator and in the denominator, okay? So this kind of opens up a whole lot of fun stuff in math and kind of puts into, I guess, light everything we've kind of been doing so far. So remember, I think it was like chapter 3, we were talking about the graphs and the domain and range. All right, that's going to come into play here. We're going to talk about factoring. That's going to come into play. Okay, so let's start with 6.1. 6.1, rational expressions and functions. Rational expression, a fraction whose numerator and denominator are kind of easy. Expression. This is like, I could have done that. You went to school for how many years? Just to write expressions? Yes, Lynn, I did. Okay, so here are examples. We have 3 over x plus 4. We have 2x over x squared minus 4x plus 4. And we have x squared minus 5x over x squared plus 2x minus 3. So why am I kind of like saying this is kind of like a culmination of a lot of the stuff we've been doing so far? Well, a couple things we need to make a note of. What can't we divide by? 0. So you might want to make a note of that. You cannot, maybe underline it, divide by 0. Can't do it. No bueno. Bad things happen. Okay. Now, why does that come into play here? Well, look at your denominator, right? At some point, that might be 0, right? Because there's an x in there. X has changed. So I now have to think about, well, my domain now changes. Okay, I can't have 0 in the denominator. So it's going to be kind of like all reals except for something. Okay, and I think you guys can kind of see where I'm going with that, right? When would the denominator be 0? Well, when x is -4. Remember 5, 6? We were setting these things equal to 0, right? We're kind of doing that. And then we were talking about what? Factoring. What are the factors of 4 that add up to -4? Do we remember? All right. X minus 2 times x minus 2, right? And we were set those equal to 0, and we get 2. Then what are the factors of -3 that add up to 2? I know it's been a long weekend for me too. 3 and -1, so we would have like x plus 3 times x minus 1. All right. I'll talk about the top in a minute. All right, but we would set these equal to 0, and we would have like, oh, x equals -3 and x equals 1. But now recall domain. Domain is where the function exists. Meaning, like, if I plug in a number, I get like a number out, right? And then we talk about generally like, oh, well, it could be any number less than 5, right? Because it only goes up to 5 and then stops, right? So there's a lot of fun stuff we can do with this. But the big thing with rational functions is simply this. You can't divide by 0. So that means what we're going to have to do is we're going to have to do a lot of factoring and then setting the denominators equal to 0. We're going to talk about what happens, okay? So in rational functions, the domain will not include any value that makes the denominator 0. So remember my shorthand for all reals is the R with like the two legs. A lot of fun stuff about to happen. Been waiting all year for this. I'm not talking about math, I'm talking about baseball. Phillies lost 10-2, I believe. Oh, exciting spring season. Can't wait. No, just kidding. I'm really looking forward to math every day. All right. So basically everything I just talked about, they wrote in a little box right here. So, all right. Let's talk about A and B, and then A and B again. So fun stuff. One, you guys might find it helpful. Pull out your calculator. Okay. I'll try and graphically show you and then algebraically show you. All right, for those of you at home who already have your calculator out, go up to y equals and plug in 4 divided by x minus 2. So I'm going to clear that out. 4 divided by parenthesis x minus 2. And then hit graph. Oops, I have my stat plot on. All right. Huh. Look at that. You guys don't even know what you're looking at, do you? Whew. When you hit y equals, does it look like that? Do you forget parentheses? Yeah, buddy. All right. So parentheses are going to help you out. So here we go. I'm going to try and do my best here. Okay. Trace. Where's that for me? Ooh, fantastic. All right. So I'm going to trace out my graph. I want you guys to notice something. Okay. 1, the little flashy dot thing. That's on my graph. Okay. Just hit trace. And what I'm going to do is I want you guys to notice I'm going to go to the left. Okay. For the y value, I'm not worried about x here. For the y value, because we have domain and range, right? What number does it look like my y value is getting really, really close to? Zero. Okay. So my y range is getting really close to 0. Do you ever think it hits 0? No. All right, we're going to talk about that. Now, let's talk about the x value. Let's go the other way, right? Because we have like two main things going on here. We have like this going along the center, and then we have something happening like right in here, right? Where the graph splits, agreed? So we have like two splits of the graph. So this red line I drew in, well, that's the range, right? That's going to be affected on the range. So we can see that my little dot is getting really close to that red line, never hit it, and it was getting really close to 0. Now, if I go for my x value, my domain, watch the x. Watch this number here. Tell me what number does this get really, really close to? If you want to follow along on yours, okay, try and make a prediction where you think it will get. Where'd the dot go? Oh, it went to the other graph, right? So where do you think it switched over? From the left graph to the right graph. At what line is that break happening at? 2. Okay, 2. Now, these things are called asymptotes, meaning they're like limits. They're like, where does my line get, but never actually touch, okay? So as we can see, my graph gets really close to those lines, but it never actually touches them. If I zoom out, it didn't help too much. If I zoom out, I'll zoom back in, see if I can get this a better one. That's why. Yeah, this will work. See how I'm along here? Do you see how my line just keeps going down and down? I'm trying to get a better one. Let's see. Nope, it's not going to do it. All right, it's not going to do it for me. But do you see how the graph never touches the y or the x-axis and it never touches to that vertical line? All right, let's talk about this. Let's look back at A. All right, how did I know where these things were going to be? First off, the easiest one to see is that vertical line, right? That vertical line, Lance, you said x was 2, right? Well, let's look at that denominator. X minus 2 equals 0. How would I solve that? Add 2. X equals 2, right? This is going to be a vertical asymptote. All right, meaning this is where my line or my graph will get to, but never actually touch. It's not a part of my domain. All right, I know it's not part of my domain because we're talking about x values. So my domain here would be all reals except x equals 2. That would not be there. Okay, x can't be 2. Because when x is 2, well, notice I have 4 over 2 minus 2. 2 minus 2 is 0, and I can't divide by 0. Do you guys see that now? All right, kind of makes sense. Now let's talk about that vertical or that horizontal asymptote, right? Now this one's kind of like a little bit more abstract. You ready for this, Julia? I'm gonna do my best. All right, it's been a year since I taught. Good. All right, Julia, we have a fraction, right? The numerator remains constant, right? 4 is not changing. Agreed? But the denominator changes because that's where my x is, right? Yeah. Now, when I plug in a really, really big number, right? I have a really big number minus 2. Does that really change anything? Think of it like 1,000, right? 1,000 minus 2 is like 998. Didn't really change it too much, right? What is 4 divided by like 1,000? It's like really small, right? What happens if I had like 10,000? 4 divided by like 10,000. What happens there? It's even smaller, right? What number would that appear to be getting close to? Think about it. You have 4 over like a huge number. Isn't that getting really, really close to 0? It's getting really, really close to 0. So that's where this is like abstract, okay? So your range, okay, which I know they're not talking about, but I like to talk about it at the same time. My range is all reals except, okay, y will never equal 0. It can't, right? 4 over like a huge number, it's always going to be slightly bigger than 0. It's going to look like it gets to 0, but it's never going to actually get there. Does that make sense to you? Do you see how it's like really abstract? I can't like mathematically show it to you. I have to reason it with you. So let's just think about it, okay? And the way you think about it is this. You pick really big numbers, all right? And you see what happens, okay? And then you rationalize to yourself, well, yeah, okay, it's going there. Those are called limits. And part of them are what they call them are asymptotes, which just mean like a vertical line or a horizontal line. So I'll get you in a second, Lance. So when we go back and we look at this, you can see this vertical line at 2 exists, and my graph never crosses it. It's x equals 2. And then you see this horizontal line right here. That's at y equals 0. And my graph never crosses. So this is a horizontal asymptote, and that's a vertical asymptote. Lance. No, it won't. Okay. It won't always equal 0. It depends on what I'm doing with the function. Okay. All right. If I had like a +1 here, okay, well, that's going to change some stuff, right? If there's an x on top, we'll talk about that. All right. I'm going to try and take it pretty slow so you guys can like actually, it's abstract, you know? So we kind of have to like build our minds to kind of think that way. I've been thinking this way since I was like, I don't know, a wee little lad, and I got like a calculator for a Christmas present. Okay. So you guys have to kind of think about it just a little bit different. Like adding and subtracting numbers, we all thought that was math, but math is much more. It's like abstract. You have to rationalize and reason and all that. All right, so let's look at the next problem. If we look at B, 2x plus 5 over 8. All right, let's think about this. What kind of things really give me problems, right? Dividing by 0. Am I dividing by 0 here, Hannah?
What'd you say?
Hannah, let's look at the denominator, right? This guy. Will that ever be 0?
No.
No. So in reality, this looks kind of funky, but it's really not, because the denominator can never be 0. And that's a problem we often have, right? Can't divide by 0. So my domain is all reals. Now, Kailana, you asked, well, what if the x is in the numerator, right? Well, watch this. Divide by 8, right, Kailana? Can I break that up like that? Are we allowed to do that? What's 2 over 8? Isn't that 1/4? Plus 5/8. Doesn't that look like y equals mx plus b? So here, my range would be all reals as well, because I don't have any issues. All right, there's no like, I'm not dividing by 0. I don't have square roots, so I'm not taking the square root of a negative number. All right, now to prove it to you, and this is why the calculator is pretty handy, type it in. Go to y equals, parentheses, 2x plus 5 divided by 8. Hit graph. Look at the graph. Right? Doesn't that look like a line? Are there any issues with a linear equation? No. Linear equations have domains that are all reals, and they have ranges that are all reals. Okay? And you can see the difference between the last one and this one. Kaylin, you okay with it? Can I see the difference? See how I kind of proved it algebraically? By breaking it up, making it look like y equals mx plus b, and then being like, oh, well, we have no problems with that stuff. All right. Let's try and do A without a calculator, okay? First thing we need to do, let's look at that denominator, right? X squared minus 16. Jay Patel. Jay, do you go off to play Fortnite? Justin. No, mute.
Yeah.
Huh. Justin, what are the factors of -16 that add up to 0?
4, 4, and -4.
4 and -4. So the first thing I'm going to do is I'm going to do x minus 4 and x plus 4. And then I'm going to set each one of those equal to 0. All right. So I know in my domain, I'm going to have all reals, because I always start with that, except x equals 4 and x equals -4, because that's when the denominator is 0. You guys see how I got to that? All right. I know it's not asking for range, but let's talk about it. Okay, this one's going to really rack your brain. What do you think happens range-wise? Any guesses? All right, let me ask you this. Who do I want to pick on? Cody Wooler. Cody.
Yeah.
Cody, I got a question for you. Okay. Are you ready for this? Let me sit down for this. Okay. Cody, I want you to think about this. Which type of function gets bigger quicker? Linear or quadratic? Does a linear function go to like 100 quicker than like a quadratic function?
Wait, so what are the two options again?
So I'm wondering which one gets bigger quicker, linear or quadratic?
I have no idea, but I'll just go quadratic.
You are correct.
Yeah.
Think about it. Squaring a number gets big real quick, right? Okay. Linear is like multiplying, like 5 times 10, right? That's 50. 5 times 11, that's like 55. That's like linear. But quadratic, well, 5 squared is 25. 6 squared is 36. 8 squared is 64. Do you see how quickly it goes up? So quadratic gets quick, or it gets bigger quicker. So where do you think this is going to go? Well, the numerator, okay, will be overwhelmed by the denominator. And what do I mean by that? Well, let's look. Type it in. See? Looks funny, right? But think about it. It like kind of goes to 0, right? Because the numerator becomes like overwhelmed. Look at all these lines, right? That's at -4. That's a -4. But like over the long term, look where it goes. It goes to 0. It goes to 0. Do you guys see that? So long periods, okay, what we have to start thinking about is what happens over long periods of time. And in this case, I kind of made an assumption like before I started, I was like, hey, over a long period of time, I know this denominator is going to go to like infinity quicker than the numerator, meaning eventually this will overtake everything and just kind of drive the function. All right. Does this kind of make sense to you guys? A little bit, just a little bit. All right. This is like calculus stuff and pre-cal stuff, but I try to talk about it so that you guys have heard it before. Okay. So here we were kind of feeling like we might have like in the first one, like a limit at 0, like there'll be like an asymptote at 0. And we see that, hey, over here looks like it goes to 0 and over here looks like it goes to 0. But like what's happening here? oh, we went through 0. Why is that? Oh, well, let's think about it. I can plug in 0, right? 5 times 0 is 0, right? Plug in 0 in the denominator. We have 0 squared minus 16. It all works out. Okay. So we were making assumptions and then checking. Any questions on that? No? You guys stink at lying. You guys are not good at lying. All right. Let's look at B. All right. Again, when I'm looking at this, before I'm starting to think like, oh, hey, over the long period of time, this denominator will start to overtake the numerator because we have an x squared here, right? We have a linear function over a quadratic function. I'm thinking over long term, this is eventually going to go to 0. That's what I'm thinking. Okay. Will I go through 0? Maybe. I don't know yet. I have to kind of look at it. I have to do the nitty gritty math. First thing I want to do though, is I want to look at the denominator and I want to see if I can factor it. Can I factor x squared minus 2x minus 3? Yeah. The factors of -3 that add up to -2 are x minus 3 times x plus 1. I said each of those equal to 0. That gives me that. So my domain is all reals except x equals 3 and x equals -1. They're not going to be there. I'm going to have those asymptotes, those lines. It's going to be broken up. Okay. Will I have any issues with my range? Probably not, because it kind of looks similar to A. And we saw how A was broken up. I just think my breaks are going to happen at -1 and 3 here. All right. You guys okay with that? Okay. I think that's where I'm going to stop today.